All right. Seems like a lot of y'all want to know how to debug applications in Kubernetes. We're going to talk about that. Wow, that's awesome. Okay, there were wooers. I love wooers. All right, so I'm Michelle Noorali. I've been working on cloud native tooling for the past few years, mainly around deploying and managing applications on Kubernetes. And even though Kubernetes was very early a few years ago, I was interested even back then in the app space on Kubernetes because that's where my background is. So before this, I worked on a Ruby platform as a service in that PaaS space on a particular PaaS that was composed of one big app and a lot of different microservices. And before that, I was a web developer working in the world of Ruby on Rails and JavaScript. I'm going to add some fun facts. I really love tennis. I'm really bad at it. I love coffee, but it gives me anxiety, so I should not drink it so much. And I've learned how to excel at packing travel luggage for the past few years, but I really don't want to travel anymore. So that's my life right now.
Hello, everyone. I'm Radu. I'm a software engineer at Microsoft. I'm a co-maintainer of Draft, Brigade, and the new Cloud Native Application Bundle projects. I'm a Go and TypeScript developer and almost Rust developer. And I work mostly on open source cloud native developer tooling. I absolutely love music. I'm a lousy piano and guitar player, and I love bicycles.
So our thoughts today are around this particular premise that for as long as we write software, we will always introduce bugs. So it's important and we'll always need to be able to debug our software.
And it's worth taking a step back and try to remember what was like before we were in the world of microservices, specifically when we were developing large monoliths, especially when we were developing, for example, .NET or old Java applications. We used to have one place where the application was running, where I could see all the logs of my application, where I could build my application, put a breakpoint, and evaluate the state of my request, right? And this is true for .NET and Java applications,
And I have the same experience, even though I didn't work in an IDE as a Ruby developer. I used Vim and Emacs mainly, but I did use a debugging tool called Pry, which was a REPL tool. And so we basically add this Pry library to our application, throw a binding.pry line somewhere in our code base, and run our code. And then it would freeze at that particular line. And then we'd be able to evaluate current context, introspect into variables, and things like that. But for the most part, we are no longer writing monoliths. We're writing microservices. And containers and Kubernetes have become this clear platform of choice for developing and deploying them. And this has allowed us to break down these incredibly complex solutions into smaller, easier to understand components that are independently deployable and loosely coupled. That has organizational benefits, like it allows teams to have specialized areas of concern, and it enables them to ship changes faster. But having a distributed solution with so many moving parts means that accurately pinpointing a problem becomes significantly harder.
And as an industry, we've been very good at developing solutions, for example, for centralized logging, distributed tracing, and lots of other tools that allows us to understand the lifecycle of a request and how to understand the problem of a request. But breaking down to how do we understand the problem right now, how would people in the audience would go about understanding what the problem is with a pod? Kube control logs, right? That's the first thing we do when we understand that something's not working right. But unless the problem is in the specific pod that we're trying to read the logs from, it's not going to be of much use for us. If the problem is in the ingress or in the service or somewhere else along the line of our request, probably there's a broken secret, right? We have no knowledge of understanding that. And that's where distributed tracing or logging comes in, right? Tools like Grafana allows me to trace a particular request through all of its lifecycle. And on top of that, the industry has also been working on a lot of tooling for debugging. For example, both Google Cloud Platform and Azure offer paid services to do debugging on top of Kubernetes. The thing is, both of them only work on their respective cloud platforms. We're looking for something that is open source and works on every Kubernetes cluster out there. Now, I cannot recommend the Squash debugger enough. And with that, take a look at Edith Levine's KubeCon talk from last year. Squash is a really, really awesome tool that allows you to debug across microservices. The only thing about Squash that I want to mention is it requires in-cluster components. And on top of that, it requires privilege in-cluster components.
But you might be wondering, like, why do I want to debug on Kubernetes at all? Well, we're at a point where we get to a point where there are too many services we have to run locally. You might also have some security constraints that don't let you do things outside of your cluster. So some in-cluster dependencies, like you might need access to private APIs and data. You might have IP restrictions or things of that nature. And also, debugging on Kubernetes lets us get closer to a production-like environment. You have access to all of the abstractions that go along with your actual application container image, like your Kubernetes services, ingress, secrets, things of that nature. So how do you debug an application on Kubernetes?
Any thoughts?
Brave souls. Somebody said something. Yeah. Yeah, we do that. We do that a lot.
Quite a lot. Any other ways to debug an application?
Open tracing. OK.
That's a good one. OK.
You got more? OK.
The thing, as it turns out, the thing that we do most often is actually print line something, rebuild the application, and redeploy it. Read the log, understand something or not out of it. And this is what and this was our talk.
Yeah. Yeah, this is it. You should keep, no, I'm just kidding. Yeah. OK, so all right, I'm on my Kubernetes cluster. Stuff's going wrong. What can I do, Radu? What can I do?
Open Stack Overflow.
So that's a magic Kate's ball. If you're really lost and you need some source of random inspiration, we're handing them out at the Azure booth. There's definitely a more scientific way, though, to debug your applications on Kubernetes.
Yeah, and this is where the actual fun ends. Because to actually debug an application on Kubernetes in the true sense of debugging, you have to, first of all, build your application for debugging. That might mean including debugging symbols in your binary, starting the application process with some flags like --inspect for Node.js or any other way that you build an application for debugging in your platform. Then you have to actually build a container image using the binary you just built. You have to push the container image to a container registry. Then you have to update your deployment manifest or Helm chart with the newly built image. Wait for the pod to be running. Then you can either inspect the application, forward your port, and check out the application. Or if you want to actually attach a debugger, then you will want to expose the debugging port, forward that locally, and then attach a local debugger on it. Those are a lot of steps, right? And there are tools that make it easier to solve some steps of that entire process, such as Ksync synchronizes your local file system with the file system inside a pod. There's telepresence, which redirects traffic from your cluster to your local machine for a specific service. There's draft and scaffold, which rebuild the container image, push it to a registry, and then update the deployment. And both of us, we've been working on drafts for quite a while. So Michelle, do you want to show a bit of draft?
OK, yeah, absolutely. So I'm going to switch this thing, and I need to put this
I think it should be
mirror.
duplicated.
It's not. I always have this problem. All right, I'm going to mirror.
How do we solve this? Kube control config view.
Where is the mirror thing? Oh, the other window?
Arrange.
Oh, show mirroring options. Display what?
Arrangements.
Oh. Oh. Thank you. Be here for the next 30 minutes. Okay, cool. That was the demo. Okay, so let's see. Okay, so in the draft repository, there's an examples directory, and there's an example called example Go. And in this example, you'll find a simple web server in the main.go file. And this just listens on port 8080 and says, hello, KubeCon, remember to do your laundry. That should say, remember to do your laundry as soon as you get home, because I always forget. So we are going to do a draft up. And what this is going to do is it's going to build our container image. It's going to release it to, or it's going to push it to a container registry. And then it's going to deploy this application to Kubernetes using a Helm chart. Now, if you'll remember, or if you noticed, there are some more files in my directory. There's a Docker file, which tells you how to build your image. There's a charts directory, which contains some Helm charts to deploy your application. There's a draft.toml file. This is some metadata to help draft deploy your application. These all come from draft packs, which we'll look at later. All right, but I'm going to do a draft connect. And what this does is it gives you a local tunnel to your application using Kubernetes port forwarding in the backend. And we're going to go to our browser. And I'm going to shut off Slack here. OK. And yeah, it says, hello, KubeCon, remember to do your laundry. OK, we're going to go back to our app. We're going to Control-C out of that. We're going to edit our application. Is the font OK? If the font size is not so great, let me know. We'll just change this to Hello World. And save that. Do another draft up. And that's going to rebuild my container image, push that to a container registry, deploy my Helm chart using the latest image so that we don't have to do any of that by hand. And then we're going to do another draft connect. We're going to go back to our browser in a second when it loads. Great. We're going to grab this URL. You can specify what port you want to connect to, but this just gives us a randomly generated one. So our application updated, and that's great. But you might be thinking like, hey, you still have to have like a Docker file and a Helm chart and a draft.toml file, and that's like a lot. And it is. So I'm going to go to this example Ruby application, and I'm going to delete my Docker file and draft.toml file in my charts. And now I just have my application. If I run a draft create here, it's going to detect the language of the application, and it's going to grab something called a draft pack, which is essentially just a directory with some files in it. The files are the Docker file and the charts and the draft.toml file, and it's going to place it in my directory of my source code, and then draft can use that on a draft up. You might be thinking, well, I don't need auto language detection, and that's cool too, because that's really just nice magic default behavior to have. If you have some custom Docker files that you use for your organization, you can create a draft pack for yourself, and then you can run a draft create and then override the default behavior using the pack flag with some custom Ruby pack that you made. And that will have your custom configuration for your Docker file and your Kubernetes manifests in there. All right, so that's all well and good. But let's do something. Oh, actually, let me go back to this. Oh, but it's OK, great. Oh, that worked. I have really bad luck with those kinds of things. All right, so just to recap real quick, that was a few different things. We did a draft up, which built and pushed our image and then deployed our app. And we did a draft connect, which gave us some local tunnels on the exposed container ports in the Kubernetes application pod. And all of this was powered by draft packs, which are great for scaffolding your Dockerfile and Kubernetes configuration. So that's all well and good. But let's do something a little more interesting, a little more complex. So what I have here is an application with an Angular client front end and a Node back end. And I've already deployed these, actually. I'll show you the pods that are running. I've deployed these just to save a little bit of time using draft up and all of that. But I'm going to do a draft connect in my Angular client front end. So we're going to grab this localhost URL right here, port 8081, and then we're going to go here, and I already have it, so I'm just going to refresh it real quick. And I'm going to have a list of to-dos. I'll add something. What do you need to do when you get home?
Probably laundry.
OK, laundry. We really like clean clothes. And then after I do some laundry, I'm going to have I'm going to need something else to do. But first, I want to tell you another thing that I've done to my cluster, which is I've installed something called Linkerd, which is this simple service mesh. Basically, I installed the CLI on my local system, and then I installed the control plane using like one command. And you can see the control plane running. This is a bunch of components. So I'll go here. I'll go anywhere. It's all in my Linkerd namespace in Kubernetes, so you can see that running. And yeah, and this basically, another thing that I did is after I deployed my application, I ran this this line, which grabs your application deployments and it injects a Linkerd sidecar and it updates your deployment manifest. Okay, so now we have our application pods, we have our Linkerd sidecars. Why does that matter? Okay, that matters because you get this nice little dashboard with information about your requests and responses. So when you have one service, it might be a little easier to see what's going on. But when you have lots of services, you need a way to be able to track the requests and responses and what codes you get back and all of that. So I'm going to refresh this guy. We're in the top section. This aggregates those requests and responses. And I'm just going to hit start recording. I'm going to refresh this one more time. I'm going to check some stuff off. I've done everything. What else? What do y'all need to do when you get home from KubeCon? Laundry. You're right. Oh my gosh, so much laundry to be had. Great. What kind of detergent do you use? Laundry. Okay. All right. So this down here is a button. I'm going to click it. I'm going to have after everything. I need something to do, so I'm going to get something to do. And look at that. I have an error. So if I go back to Linkerd, to the Linkerd dashboard, then I will see these requests and responses like pop up. So I can even see here that the request came from my Angular client. It's going to my Node backend. And then it's all the paths that I'm hitting, some statistics around count and time, and the success rate. And what really gets me is this little red right here. It looks like when I hit /random, which was the path that we hit when we clicked that button, I didn't get a success error code. So I know that something's wrong in my Node backend. So I'm going to tell Radu, who's my programming pair, that, hey, I see this problem. Let's figure out how to debug it right here.
Well, first of all, I think it works on my machine.
OK. That's cool. That's cool.
So I have the exact same setup on my cluster as well, which means I have a Kubernetes cluster. I have Helm configured on my cluster, and I have both the Node.js backend deployed and my Angular frontend. And I have the same application, and I'm refreshing the app, and I'm trying to press this button. And yes, this is a button. This is the extent of my web development skills.
Radu's CSS skills are wonderful.
And apparently, I can also see the problem that Michelle is seeing on her application.
You got to replicate the issue.
So at this point, what I can do is open VS Code. Is that large enough? Yeah. OK. So I can open VS Code with the source code for the Node.js backend. And because this is a draft application and I have the Visual Studio Code Kubernetes extension installed, what I can do is start debugging by pressing F5. And at this point, VS Code will start building the application using draft. So it's doing a draft up, which builds the container image, pushes it to a container registry, and then deploys the application on the cluster. It waits for the pods to be in running state. Then it will port forward all application ports locally on my machine on localhost, including the debugger port for Node.js. And then it will attach the Node.js debugger on my process that's running inside my Kubernetes cluster. So all of this is powered by the VS Code Kubernetes extension, which I really recommend you have a look at if you use VS Code. And at this point, the debugger seems to be attached on a process that's running inside my Kubernetes cluster. So if I go back on the application and I just refresh it, in theory, I should be able to hit a breakpoint from the Angular client who's making a request to the Node.js microservice, and I catch that using a breakpoint that I set up earlier in VS Code. So at this point, what I can do is see all of the information for the request and the response, evaluate variables, have a full debug console. So request.host, for example, is to-dos API node debug. And right now, in theory, I should be able to debug the problem that we were seeing on the give me something to do button. So if I press that, oh, I just catch the breakpoint that I set up earlier, and apparently this is the issue of the problem. It's throwing a new error every time I press that button.
It's definitely an error.
So what I can do at this point is exit the debugging session. And remember that I actually tried solving this problem once again.
Oh, snap.
So we want to get a random to-do item with our application. Apparently, some other team wrote a Go microservice that just gives you a random to-do item, right? So hopefully, I can be able to use the microservice they just built, and let's build the application again, which this does again. Draft up does a Docker build and Docker push, then deploys the application using Helm, then forwards all ports and attaches the debugger.
So
and
now your service is available to use in your cluster
yes.
from the other service.
And now let's have a look at the Go microservice that we're trying to use and do the same thing for this as well. This is just another, it's mostly the example Go program. It's nothing special about it. It's just a simple web server. And we're doing the same thing, right? Draft up and draft connect. If you're not familiar with the VS Code extension for Kubernetes, then it allows you to see all your clusters configured on your machine, as well as see all the nodes, workloads. You can see the deployments, jobs configured.
You can also exec into your pods from VS Code. It's terrifying.
You can exec into your pods. You can get the logs. So if you find yourself writing kubectl get pods or k get po 700 times a day, then this might be good for you. So in theory, the debugger is attached. So what we're trying to do right now is press the button to give me a random to-do item. This hits a breakpoint in the Node.js microservice, which in theory is going to create a breakpoint on the Go microservice that I just deployed earlier. And we have that hit as well. So remember, we have 3 microservices in our cluster: an Angular front end, a Node.js backend, and a Go microservice. And we're able to debug a request coming from one microservice to the Node.js backend and to the Go in VS Code using draft and the Kubernetes extension.
I know. I've seen that demo so many times. And it gets me every time. I'm like, oh my God, that's so cool. It worked. All right, so that feels like magic, Radu. Oh.
It's quite the opposite of magic. It's plumbing. So the thing is, we're not doing anything but take a tool that is able to iterate on your application, so continuously deploy your application in a cluster, then forward the port and attach a debugger. In theory, you could be able to use any tool and change any tool that we're using in our workflow with your own. So the thing is, there's not one single tool that allows you to have a workflow like this. That's why we're trying to put together a workflow that allows you to essentially build your application for debugging, create the image, push the image, redeploy, attach the debugger, and so on and so on. And you can definitely do that manually, but if you're doing that 5 times in a row, you've already wasted 15 minutes only deploying the application and attaching a debugger.
So what about debugging across instances?
Well, this is probably the most asked questions that we get when we show this thing. The easy way we try to solve this at the moment is whenever we redeploy the application and try to attach the debugger, we simply started with one instance, right? So this is not something that will solve all of your problems. And we're actively looking into integrating with a service mesh to redirect traffic to a single instance. But this is currently work in development.
What about debugging in production?
So that is definitely something, it's my opinion, first of all. I definitely not recommend using something like this in production. First of all, if you only have one instance and you're blocking it, no other clients can get requests out of your instance. So it's definitely not something that we recommend. So just to recap what we've done here, we have an opinionated workflow with open source and pluggable components. So just like I said earlier, if you have another tool that you want to use to redeploy your application, or you have another tool to forward your ports locally, or another IDE for debugging, you can definitely mix and match all of the tools that you want.
So if you want to get involved, you're welcome to check out the draft code base. It's on github/azure/draft. Check out the VS Code extension, Linkerd. We're big fans of the user experience and the developer experience there. And we highly recommend watching Edith's talk on Squash from KubeCon Austin 2017.
So as next steps for the things that you've seen so far, number 1 on our list is performance improvements whenever you build container image. So the trick that we've done so far is we didn't actually update the application that much. So what we're trying to do is improve the performance when building application to only build the top layer that changed to your application. The next thing is we're looking into building a draft plugin for Linkerd so that whenever you spawn an application in your cluster, we automatically inject the sidecar for Linkerd so that your traffic automatically shows in the Linkerd dashboard. Another thing that we're actively trying to do is come up with best practices for configuring draft packs, as well as for well-known and popular front-end and back-end experiments and examples. As well, we're looking at pluggable builders and deployers for Draft. At the moment, Draft works with Helm very well. We're actively looking at integrating other deployers into Draft. And of course, your feature request is number 1 on our list.
Thank you so much. I think we have a few minutes for questions.
Yes. Yeah.
What's the relationship between Draft and Squash? It seems like there's a little overlap. Is it using Squash?
It's not using Squash. So essentially,
I want to repeat the question.
Oh,
so
yeah.
The question was, what is the relationship between Draft and Squash? Is Draft using Squash underneath?
So as I said at the beginning, Squash is using in-cluster components to attach debugger to processes. Draft, all that it's doing is it's building the container image, it's adding the debug information inside a container or through a sidecar container. So it's not using Squash, it's not using in-cluster components at all.
Any other questions? Yes, sir. Excuse me. Yeah. No.
The question is if Linkerd is a required component. No, we only use Linkerd to show that whenever you have multiple components, you might want to see where the requests are coming from. We could definitely have the same demo without Linkerd.
Yeah, good question, by the way.
Yes? Oh. Could you repeat, please? No, I'm not running any services locally. So whenever you see a local host URL, that's actually running inside my cluster, and all the ports of my application that is inside the cluster are forwarded locally.
Yeah.
In the same way that kube control port forward works.
Yeah. So we deployed everything to a Kubernetes cluster. In this example, it was Minikube, but you can deploy it to a remote cluster. We just didn't do it because of network issues and all of that.
How would you handle something like this in a multi-person team where there's multiple people trying
So the question is how you would handle something like this in a multiple-person team. Well, it depends on how your team works and how they use Kubernetes clusters. So you can definitely have one cluster per team, or have one namespace per person in the team, or one namespace per person or per team. It boils down to how the team works. In theory, this allows you to debug the same application from the exact same deployment from 2 instances with no problem. So the question is if you can use this to attach to something that's already running. The answer is yes. Behind the scenes, we're using the VS Code debug process. So any debugger that's supported by VS Code and that can do remote debugging can be used. And yes, it's something on a feature list that we have to support right now.
Does it support Visual Studio proper?
Sorry?
Visual Studio proper?
The question is if it supports Visual Studio proper, for the full for Windows. There is an example of using Visual Studio full for this. I can definitely put a link in there for you. But it's not something that our team is actively working on.
Any other questions? Yeah, we'll upload the slides to Sketch and online. Okay. Thank you all so much.
Thanks.